Welcome back. Hope you enjoyed your Thanksgiving weekend. We are ready to start ourselves a new chapter on exponential functions. This is a short unit, so we'll be able to finish this between now and the winter break. So no quizzes or anything this unit. We will just take a short unit test in a couple of weeks right before we go on the holiday. All right, so exponential functions, what are they? Well, they can be written two different ways. They can be written in function notation. That's this one over here on the left. And what makes it special is that our missing number is the exponent. Or they can be written in standard notation here and using y instead of the f of x. But again, the key is our missing number is an exponent. So that b isn't going to be there. You're going to see numbers in that spot. So here are some samples. F of x equals 5 to the x power, or y equals 14 to the x power, or even f of x equals 2 times 3 to the x power. All of them having the same thing in common. Our missing number x is the exponent, which is why it's called an exponential function. So for today, we're going to be graphing these. It takes a couple of simple steps. The work isn't very hard, but you probably want a calculator, and again, the one on your phone is perfectly good. You don't need any special buttons for this one. So the first thing we're going to do is we're going to substitute some values for x and solve. And I'm going to be nice and give you the values for x that you need to substitute with. That way you don't have to worry about picking anything weird. All right? So substitute answers for x and solve, and then the answer we get is the y coordinate. And since we've already picked the x, we're going to end up with an x and a y coordinate, which we can then do step 2. Plot the individual points using the x that you started with and then the y that you got as your answer. And then there's two different possibilities on the way the graph will look. On the one on the left here, the graph is actually flattening out at an asymptote of the x-axis over here on the left, and then to the right it is shooting up towards infinity. Now the other one is just a complete flip in reverse, where it is flattening out at the x-axis on the right-hand side. That's an asymptote. Or, again, on the left-hand side, this time it's shooting up towards infinity. So in two different possibilities. All right, let's try one. Okay, so the first thing we're going to do is we're going to find some individual answers. Now, I've already given you half of the answer. So, for example, on this first point, I've already told you that x is negative 3. The question is, what's y? So to find it, we're going to plug it in. Y equals 3 to the negative 3 power, which ends up equaling 1 over 27, and 1 over 27 as a decimal is 0.04. Now I want to graph that spot. So over here to the left and up 0.0, essentially right on the x-axis, really, really close. Like I said, that x-axis is an asymptote in most of these particular drawings. All right, now we're going to try it again. We've got the x-coordinate, negative 2. We want to find the y-coordinate, so we're going to plug it in. So this time we do 3 to the negative 2 power, which makes 1 over 9. And 1 over 9 as a decimal is 0.11. Still extremely close to 0, but a tiny bit higher than that last one. Now we'll try another one. We got the x-coordinate, negative 1, so let's plug it in. 3 to the negative 1 power equals 1 over 3, which is 0.33, or 0.3 repeating. So I have another point to graph. At negative 1, I'm up at 0.33, so a little tiny bit higher, but not very much. Now let's try another one. All right, so the next one, we got the x-coordinate, 0, so we're going to plug it in. 3 to the 0 power. Well, anything to the 0 power makes 1. So first non-decimal answer at least. Now try another point. We know the x-coordinate's 1, so we're going to plug it in. 3 to the first power, which equals 3. So at 1, I'm going up to 3. All right, let's try another one. Next point, we know that our x-coordinate's 2, so let's plug it in. 3 to the second power, well, that makes 9. So I should have a dot at 2 and 9. And the last one, I know the x-coordinate's 3, so plug it in to find the y-coordinate. 3 to the third power is 27, so I'm going to graph 320. Oh, it's off the screen, so obviously I can't graph that one. So you can see it's on the left-hand side that we've got the flattening out at 0, and on the right-hand side that we're shooting up towards infinity. Again, the other option would have been complete reversed, flattening on the right and shooting up on the left. Again, those are the only two possibilities you're going to get with exponential graphs. All right, so your job is just to do a couple of these today to kind of get used to how they look and how things work out. All right, let me know if you need any help. You know how to find me. Good luck.